Yeah. Yeah, time change is not, I do not approve. Mm-hmm. Not fun.
What should have been time change and customizing a drum head took my sleep.
Customizing a drum head. Could we get more specific? That's very niche of you, Lucy.
I'm customizing a drum head.
For your dad?
Yeah, with Sharpies.
Oh, okay.
It's the bass drum, so it's huge.
Very cool. Give me 1 second. I need one pump of lotion. Alright. Alright, people.
So Lucy, have you seen those memes where they're like those gotcha memes or memes where they're like these people react to what their name means and it just shows an image and like for and like for example mine would be a bell because I'm Annabelle.
Alright, I have something for y'all. You don't know whether you'll be excited or scared.
I got it.
Oh, go ahead. I have your final exam review now, so that you have plenty of time to work on it, and with it is a bonus. So you get like, Annabelle, this is your exam review, and it's not punched, so you can stick it in one of those pockets, but with it, you also get this. Obviously, the whole thing's optional, although I highly recommend that. This, let me show you real quick. This is for practicing balancing equations, and when you find the correct answer, it tells you what color, and then you color the mandala. And I know some of you are very crafty, artistic people. That's obviously optional, but it's just additional practice, so that's always good. And Marissa, this is you.
Might give my sister that.
There you go. And Hurley, this is you. Miss Lucy, this one is you. And just to give this one is yours. There you go. So you can start practicing. Now remember that in your student Dropbox, you have that little folder that says final exams. You get in there, you can do reviews. And there's Jeopardy in there too. Okay? Yeah, Jeopardy reviews. Everybody loves Jeopardy. So there's Jeopardy in there too. So I recommend you do both, because if you practice Jeopardy and if you practice this final exam review, you should be pretty good to go. Pretty good to go. I don't think y'all's final is too hard. Yep, we are on 27. So let you guys get ready. Oh, Alexa, turn the kitchen on. Found another one. Okay, get 27 out.
No, my water bottle. Yeah, my
Okay, let's roll with it. So today we are going to start talking about our oxidation reduction reactions. And you remember last week in lab, we had an oxidation reduction reaction, right? And I said, well, we're going to learn more about that. So today we're going to do a redox titration in lab. And redox is just an abbreviation for oxidation reduction. So you have the re from reduction and the ox, or yeah, read from reduction and ox from oxidation. So you can call them oxidation reduction reactions, or you can call them redox reactions, where we kind of reverse those two words, but ox-red doesn't sound right? You don't want to say an ox-red reduction. That sounds silly. So redox just sounds better. So that's what we say. All right. So let's roll and see what we can learn, or what we did learn with our binder work about these types of reactions.
I need a black one.
Okay. Grab what you need and find it. All right, so here we go. We ready? Alrighty, let's go. First reminder before we start our lesson, your final project is coming up the same day as final exams. And you're gonna have to turn in certain parts of it for me to look at, and then you come and present the whole thing, and it's really cool. This is just a reminder, if you haven't chosen your element, to go to the spreadsheet. There will be, I just updated the link. So if you go to the Dropbox folder, it's a brand new link. It's a brand new document. The last one was glitchy and I don't know why. So I just ditched it and started over. And then there's also a link in your email this week, and there's also a link in the final project assignment. And I opened the date for the final project assignment so that you can see it in your gradebook. You should be able to see it now in your gradebook. So it's just a reminder, remember, you're going to choose a superhero or a villain, and you're going to create them based on the characteristics of your particular element. So Eunice, you've chosen already, and you chose.
I've already got the poster and everything ready except the work side.
He's good. So he chose potassium, and Annabelle, you said you were working on arsenic, right? Good one.
So the final exam, the test is on May
13.
13th, and then so we got to present our stuff on May 6th.
On 13th. You have to hand stuff in, you have to turn stuff into me earlier than that for me to look it over, but you present after exams. After we finish exams and have lunch, then everybody presents. Yep. So there will be. What's that? Ah, okay. So that's May 13, right? And then that'll be wrapping that up, and that'll be great. And woohoo, it'll be easy, right? Because you have about all year to work on it. The assignment description and the grading rubric is in your grade book, and it's also in your binder, and it's also in your Dropbox. So you should know exactly, it's very specific. Just read through it. You'll know exactly what to do. Also, secondly, our dance. This is the tentative date for our spring dance. Now, here's the thing. The dance is typically geared towards middle and high school aged kids. But if you're in my class at this level, you are invited because I know you and clearly you can handle yourself.
Well,
so, yes.
Are we supposed to dress up for it?
It is as dressy as you'd like. It's not prom level dressy, though some people do come in prom dresses, but some people come in jeans. It's
coming in a jeans.
Yeah.
Suit shirt.
You're not much of a dress girl, are you?
No.
Yeah.
Super.
I am all about dresses. So yeah, no, you do whatever works for you. You come however you want to come. If you want to come. So you all are always invited, even though technically some of you aren't middle school. Yes.
I might wear my purple sparkly jumpsuit.
There you go. Do whatever you're comfortable with. And so I will be publishing that information as soon as I've confirmed it. This is our tentative date, but I'm like 95% sure we're going to roll with that date. That means it is the Saturday before finals. So you're going to want to get your studying done and be ready to go for Tuesday if you want to come to this dance. And this will be kind of a good way to. Yes, you're allowed to bring up to a certain number of even non-homeschool friends. So if you have friends that go to public school, you're allowed to bring a certain number of guests that are not even homeschoolers if they're your guests. You just kind of have to be responsible for them. Everybody has to kind of be responsible for their own behavior. The only problem we've ever had with the dances, last year we had some rowdier kids who some boys went in the boys' bathroom and they took soap out of the supply closet, poured it all over the inside of the closet. We had to clean it up, and that was not cool. That, and sometimes kids throw their cups off the veranda railing, and that's not good either, because then I have to go down there and try and figure out how to clean them up. Don't love that. So it's fun though. We have food and we have music. We take requests all night long. It's a good time. All right.
So what's the certain number of guests?
I think it's two. It's in the, when you go to sign up, you have to read through the forms and sign and check that you approve. So it's in there. All that's information's in there. All right. So now we're going to roll with our lesson. Oxidation, reduction reactions. This right here would be an example of an oxidation reduction reaction, the one we know as combustion. So oxidation reduction reactions deal with electron transfer in chemical reactions. So oxidation involves a loss of electrons. And anybody have a further definition for it, or what you say, Annabelle?
Oxidation is the process of gaining oxygen, losing hydrogen, and losing electrons.
There you go. So it's the gain of oxygen, the loss of hydrogen, and the loss of electrons. And that is oxidation. All right. And then we have reduction involves the gain of electrons. And Eunice, what do you have for reduction?
Oxygen, the gain of hydrogen and gaining electrons.
Right.
Reduction is the opposite of.
Right. Oxidation and reduction are opposite, inverse processes. Now, here's where it gets tricky. People want to think that reduction would mean you're losing something, right? If you reduce something, if you reduce your weight, you've lost weight, right? Yeah. So reducing tends to, in our heads, mean that you're losing something. So what are you losing? If it has to do with gaining electrons, what are you losing? So you're losing the protons, you're losing the positive charge. So when you think about oxidation and reduction, and you're like, reduction, what's getting reduced? It's the positivity of the charge that's getting reduced. So if you, or no, yeah. So anyway, it's the charge. It has to do with the charge. Oxidation and reduction. I think I said that backwards, but oxidation and reduction, it's the reduction word. You have to think about charge, right? It's the charge. Okay, so oxidation and reduction occur together. So oxidation reduction or redox reaction. Anybody have a definition for that? What you got, Eunice?
Redox reactions are reactions in which one species is reduced and another is oxidized. Thus, the oxidation of the state of the species must involve.
Yes, redox reactions are reactions in which one species is reduced and another is oxidized. Remember, to oxidize means to gain oxygen. See it right there? So if you didn't gain oxygen, you were reduced, right? And another is oxidized. Thus, oxidation state of the species must involve change. Yeah. It's at the clubhouse at the front of my neighborhood. It's a real big open space. I host it every year. Yep. Why?
I think I would be able to take her anyway, but this place is really far from the neighborhood she lives in.
Oh, yeah. Yeah, that's far for some people, but it's real close for others.
But do you think you'll be able to come?
So a minute ago, I think I accidentally spoke it backwards, but what I'm trying to say is when you are reducing, right, it says gain of electrons. So if you gain electron, you become more negative, right? So that's where we're talking, that's what I meant by the reduction in the positivity of the charge. If you're gaining electrons, you're becoming more negative. So your positivity is being reduced. I don't know if I said it forward or backward, but I want to make sure that I made it clear. All right, so now this is interesting. So redox reactions. Now a strange cartoon from does anybody know what country that is?
Azerbaijan.
Azerbaijan's
It's like
chemical
here.
society. Yeah, Azerbaijan is, I think it actually was a Soviet state.
Like one of my mom's best friends come from Azerbaijan.
From Azerbaijan? Okay. So Azerbaijan's chemical society made this fabulous little GIF, actually, a little cartoon here, but it's great. So if you watch, it does explain the reaction pretty well. Oh, no. Gained 2 electrons. He ate them up. Yummy. Oh. And now they're friends. Yay. So if you gained electrons, you were reduced, right? And if you gained oxygen, you were oxidized. So in this case, if you look at the zinc gains the oxygen, right? Here's the zinc. And it was oxidized because it gained that oxygen. So watch again. Uh-oh, the copper is getting reduced because it gained electrons. So it's becoming more negative. And what's here? The zinc is going to join the sulfate, and there you go. Now the zinc has been oxidized because there's an oxygen with it. See the oxygen right there in the sulfate? All right. Silly, but kind of funny. So here's how you remember. These are great. You like mnemonics? We did mnemonics for what? What was our mnemonic assignment?
It's like a hydrogen, oxygen for like the canal.
Yeah, what would you remember yours? Was yours about oatmeal? Was that yours? No. My
Mom never hate olives.
moms never hate olives.
I
My
don't know
neighbor.
I don't
Mine
know.
was animals never mind hot dogs outside.
Okay, there you go. Yeah. So what was it for though? The order of what? How you place your elements when you're balancing an equation, right?
Metal, non-metal, hydrogen.
Yes, metals, nonmetals, hydrogen, oxygen. That's how you align your elements under the bracket when you're doing a balance equation, right? So here are more mnemonics to remember oxidation and reduction. Oxidation is loss of electrons. Reduction is gain of electrons. So if you remember oil rig, that's one way people remember it. Oil rig, as long as you remember it's dealing with electrons. Oil rig and electrons. Okay, so oxidation is loss of electrons. Reduction is gain of electrons. Okay, that's one way to remember it. Oil rig. Here's some others. Leo says grr. What does Leo says grr, do you suppose? Loss? What are you losing?
Lost electrons, oxygen.
Yes, loss of electrons is oxidation. Grr.
Gain of
Electrons is reduction. There you go. Loss of electrons is oxidation. Gain of electrons is reduction.
The leader of TMNT says grr.
Yeah. Leo says grr. So that's another one. So you can do oil rig. Leo says grr. Maybe you can come up with one of your own. Now, if you didn't say this in his voice, there's like something really wrong with you, because when you read that, you should read electrons. Electron loss means oxidation. Elmo. But if you don't hear his little voice saying that, I don't know what's wrong with you, because every time I read it, I hear Elmo saying electrons loss means oxidation. Yes.
Has everyone here seen the meme where like a puppet Elmo is yelling and then pops out of a hole in the door and goes, yes.
Have you ever seen the man that does Elmo's voice?
No.
He's big man. It is funny. You would think he's like a little tiny person. He's a really big, I'll show you. You would not, it's not what you expect at all. Because I hear that little voice and I think,
Imagine it's a kid.
no, well, this guy's he's the guy that did it for longest. He may not be the current, but it's this big guy. He's a big guy. This guy. That's Elmo. In case you didn't know. Your camera. That's Elmo. So, yeah. Kevin Clash is his name. Yeah. I don't know if he still does it, but I think he did it for the longest. Like he's like the best known for the Elmo voice.
It sounds a lot like Elmo.
Who does?
Trinity
on YouTube? Okay. Just is that gaming, or what does Trinity do? I don't know that one. Gaming. Yeah.
Subscribers you guys have.
I have 0.
I tried to search for you guys' channels, but
because there's no videos on it yet.
Oh, are you gonna make video? Do you make a lot of videos?
I don't have a YouTube channel.
Okay. Yeah. For a while, Drew had one, and he was doing a lot of stop motion Lego stuff, and it was really kind of fun.
What's his YouTube channel?
He doesn't have it anymore, but he did it for a while. He enjoyed it. Yeah, he did a lot of stop motion Lego stuff and thoroughly enjoyed it. It was fun. All right, so like I said, if you didn't read Elmo in Elmo's voice, I don't know, something wrong with you. So here they are again. Oil rig, Leo goes, or Leo says grr, and Elmo. So oil rig stands for what? Oxidation is loss. Reduction is gain of what? Electrons. Leo goes grr. So Leo is loss of electrons.
Oxidation, and gain of electrons is reduction.
Right. And then Elmo is for electron loss means oxidation. There you go. So there's multiple ways to remember it, right? Lots of ways.
Wait, leader of TMNT goes grr.
Leader of TMNT. What's TMNT? Teenage Mutant Ninja Turtles?
Yeah.
Is there a
They
line?
call him.
Oh, Leonardo. Okay. Yes, you're right. There you go. Yeah, the rat, right? Yeah. I don't know. There you go. Leo. Yeah, I haven't watched it in so long. I don't honestly know. All right, so you draw. Yeah, I know. I saw you drawing him a couple weeks ago, and it looked really cool. You had a Picasso. Yeah, you had a Picasso. That was cool. I like Picasso. That's cool. All right, so When it comes to oxidation reduction reactions, there are what we call oxidation numbers. Now, you guys are not going to be held responsible for this information. This is more for the senior lab rats, but I want you to know it's a thing. So, because you're going to do it in lab today a little bit, so you kind of got to understand the process. So, oxidation numbers are, whoop, hold on, not yet, commercial. Oxidation number is the number of an atom. The oxidation number of an atom is the charge the atom would have if the compound was composed of ions. So basically, if you have a compound, let's think about H2O, all right? If it was composed of ions and not together, what charge does the H part have, the hydrogen? You should know this because we just did this with acids and bases. Yeah, it's a plus. It's a one. Yeah, it's a +1, right? And then the OH.
Did you say plus?
Yeah, plus.
I thought-
La, 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 la. No. And then the OH is going to be negative, right? So if you have a compound like water and you were to break it into ions, its constituent ions, you would have an H plus and an OH negative, right? So that's all this is doing is it's taking a compound. And if you were to break that compound into ions, what would the charges be? And we call those their oxidation numbers. So this video kind of explains it a little better. I don't even know what this is about. Okay, yep, here we go.
Almost 1/3 of the chemical reactions taking place around us are some form of oxidation and reduction reactions. So what are oxidation and reduction reactions, and where do we find them? In the 1700s, the word oxidation originally meant a reaction with oxygen, where oxygen was added to a compound. This was because oxygen was the first known oxidizing agent. However, the definition of oxidation has become more general these days, including other types of reactions. In modern chemistry, oxidation means the loss of electrons during a reaction, and it doesn't necessarily involve oxygen. The opposite process of oxidation is called a reduction. The word reduction originally meant rid of oxygen, but in modern chemistry, once again, it means gain of electrons during a reaction. In a chemical reaction, one species loses electrons as the other species gains electrons. Therefore, oxidation and reduction reactions take place altogether. That's why oxidation and reduction reactions are simply referred to as redox reactions. Oxidation, reduction, electrons? What? Are you confused? Let's just remember the acronym LEO, the lion, GER. What this stands for is loss of electrons is oxidation and gain of electrons is reduction. Or you can remember it as oil rig, which stands for oxidation is loss, reduction is gain. That is loss and gain of electrons, of course. Now, where do we find oxidation and reduction reactions in everyday life? Number 5, combustion. Burning wood in the fireplace, burning coal, fireworks, lighting a matchstick. These are typical examples of combustion. Combustion is a redox reaction where a compound being burned is oxidized and oxygen in the air is reduced. Combustion reaction is also used to fuel the space shuttle. The fuel tank of the space shuttle contains super cold liquid hydrogen and liquid oxygen in separate compartments. When they are mixed and burnt, they form water and release enormous amounts of energy. Talking about space shuttles, do you know what happened to the space shuttle Challenger? It was in January 1986. The space shuttle Challenger broke apart 73 seconds after launch, killing all 7 crew members. Well, what caused this disaster? One investigation concluded that due to an unusually cold weather that morning, a rubber seal in the shuttle's booster rockets became stiff. This allowed the superheated gas to escape and burn through the external tank. The external tank collapsed, spilling liquid hydrogen and oxygen inside. As you can imagine, mixing liquid hydrogen and oxygen created a huge fireball. This was a combustion reaction horribly gone wrong. Number 4, corrosion. Another classical example of oxidation is corrosion. Corrosion is a process where metals are eaten up gradually by the oxygen in the air. In a way, corrosion is a very slow combustion. Most metals react with oxygen to form oxides. The oxide of iron is commonly known as rust. In this reaction, oxygen gets reduced while iron gets oxidized. Number 3, photosynthesis. Photosynthesis is the most common everyday chemical reaction. It takes place in the green leaves of the plants to convert water and carbon dioxide into glucose and oxygen. The plants use glucose as fuel or food. We breathe oxygen that the plants release into the air, and in this reaction, water is oxidized and carbon dioxide is reduced. Number 2, battery. From flashlights to mobile phones, batteries are indispensable in everyday life. Batteries have 2 electrodes and an electrolyte in between them. Alkaline batteries of the Duracell uses zinc as the anode and manganese dioxide as the cathode. When you switch your flashlight on, zinc gives up 2 of its electrons, leaving zinc ions behind at the anode. It is an oxidation reaction. The electrons pass through the flashlight, turning the lights on. Then they re-enter the battery and the cathode. These electrons combine with manganese dioxide to form manganese oxide. It is a reduction reaction. To carry back electrons from the cathode to the anode inside the battery, charged ions flow through an electrolyte solution between the electrodes. This completes the circuit and powers your flashlight. Number 1, digestion. Digestion? Who would have thought? Well, food molecules such as glucose, for example, react with oxygen in the body and break down into carbon dioxide and water. Energy is released in this process, which keeps us alive and grow. This oxygen-glucose reaction is slow at ambient temperatures outside the living cell, but it happens fast in the body with the help of enzymes. Well, that's it for today. If you learned something new today, give this video a like.
And there's a whole bunch of different examples, right? It talked about Challenger. Have any of you ever seen the video of that Challenger explosion? Never seen it? So your parents are a little younger than me, I think. Lucy, how old are your parents? Do you
My
know?
mom's in her 30s and my dad is in his 40s.
Okay, yeah. So
My-
I think everybody's parents are a little younger than me. Yeah,
My mom,
Yeah.
49. Well,
My-
just turned 49. Yeah.
my
Mhm.
mom and dad are in their late 40s.
Yeah, that's what
My
that.
parents
So
are
here's the
older.
thing. I
Close near my
I
grandma's.
guarantee you, yeah, I guarantee you, if you go home after class today and you say to your mom or your dad, even your parents, even though they weren't
Yeah,
living in the
they're
US at
pretty
the
young.
time, but even though they weren't living in the US at the time, I bet if you say, where were you the day the Challenger exploded? If they were over the age of 4 or 5, they're going to be able to tell you exactly where they were and exactly what they were doing, because it was one of those events. It's like 9/11. You say to people, where were you on 9/11? Everybody can tell you exactly where they were, what they were doing, because it was such a hugely tragic event that it gets like seared in your brain. So I was in 4th grade.
Driving home from visiting his grandmother when it happened.
On 9/11. Yeah, I know where I was. It's one of those things. So I was in 4th grade, and so in Virginia Beach Public Schools, the way it worked is like if you were in the gifted program, you went to a different school one day a week. Like you went to a whole different school in another part of town for that day. So it was my day to be at that school. So I was at the other school, which was called Old Nation Center. We call it ODC. So I was at ODC that day, and I was in 4th grade. The 5th and 6th graders, we didn't have, at the time, if you wanted to watch a video in class, you had to roll in a TV on it was this big, heavy cart, and it was a big old cathode ray box TV on top, and they would roll it into the classroom, right? And so we didn't have too many of those, so the 5th and 6th graders were watching the Challenger launch live. And most public school children across the country were watching it live. And the reason why we were watching it, there were shuttle launches all the time. But the reason everybody was watching this particular shuttle launch live was because of one astronaut on the shuttle was a special and different situation. They wanted to take a teacher to space so that somebody who was a good teacher, so that that person could go to space, learn all the things that they could learn from being in space, and then come back and teach and inspire kids about it. You could have an astronaut teach, but if they're not a good teacher, it's not going to get very far, right? They wanted a teacher. So they had a contest. And they invited all these, and hundreds and thousands of teachers applied to the program. And in the end, they selected this lady named Krista McCullough. And that was the teacher. And it was a big deal because they, instead of going through like astronaut training and becoming an astronaut, because that was your dream your whole life, this was someone who was a teacher. And then they put her through astronaut training so that she could go to space. So it was a big deal because she was an astronaut, but she was more like an everyday civilian that you would meet. Like now we send people up all the time on billionaire rockets for fun. That wasn't a thing in the 80s. So everybody got on and up they went. And they were only a little bit after 70 some odd seconds after launch, and it exploded with most of the nation watching it live. So I was not watching it live because they had limited TVs, and the 5th and 6th grade got to watch live, and that was it. But we got an announcement over the loudspeaker from our principal saying that the Challenger had exploded and they believed all 7 astronauts on board had died. And it was particularly difficult because Virginia Beach is a Navy town, right? There's like there's a naval air station there, and there's an amphibious base. There's lots of military there. And a lot of astronauts come out of the Navy and the Naval Academy and the Navy flight programs. And there were 6th graders in my school whose family friends were one of the astronauts on board. So like somebody lost somebody they knew, like all of it was interesting. Yeah.
Did it happen in Virginia?
No, Florida. Cape Canaveral. Mhm.
Something traumatic like that was imprinted in my brain.
Hmm.
The fried fish incident.
Oh no, you'll have to tell us about the fried fish incident after class. That sounds
Are you
crazy.
sure it's digested good?
That's the thing, you never know, right? All right, so here we are.
Did you ever go to the town called like Mayberry?
Mayberry, like from the Andy Griffith Show. It's actually in North Carolina, and it's based on the town of Mount Airy. And yes, I have been there.
Where you're from?
Virginia Beach.
Virginia Beach.
Yeah.
Because my great aunt lives there.
Yep.
And they went there to surprise her for her birthday.
Oh, cool.
And they passed through the town.
Oh yeah, they went through Mount Airy.
And
Yeah.
brother got sheriff's.
It's right south of the Virginia border in North Carolina. It's a cute little place. All right, so let's talk about these oxidation numbers. So remember we said it's basically if you were to take a compound and you were to break it into ions, what would those charges be? Okay, so oxidation numbers, also called oxidation state, is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. Now that makes sense too, right? If you're going to combine hydrogen and hydroxide, so H and OH to make H2O, you have to kind of give something. Remember we talked about our covalent bonds, you gain, or ionic bonds, you gain, you lose, you share those electrons, you seal those electrons. So this is all kind of coming together now, right? All right, so here's how you assign them. There are rules. Like I said, you guys aren't going to be responsible for these rules. They are, but these are the type of rules that you have to follow. So oxidation of any uncombined element is 0. So the oxidation of sodium, for example, is just 0. But the oxidation of a monoatomic ion equals the charge. So if you have a chloride, then it's going to be -1 because chloride is a negative ion, right? It's an anion. More electronegative the element in a binary compound is assigned with the number equal to the charge it would have if it were an ion. So the oxidation number of oxygen in nitrous oxide, nitrogen monoxide, sorry, is -2. That's what it would be if you were to break it into ions. So these are all the rules. There's lots of rules. And so if if you get to high school chemistry, you'll have to learn kind of all these rules, but just understand that this is a process that's happening because you're going to see it in lab and stuff today.
So it says complete in class file and binder. That means you don't take it out.
Today's lab, yeah, we can take it out for lab, but you're going to put it back in. So, and look at this. Does this look familiar? Do you remember when we had our periodic table up and we talked about how many atoms or what the electron charge on something is, right? If you're going to make a neutral atom, you're going to want, this is why these guys over here in group 1 combine really well with these guys in group 17, right? Because these guys in group 17, if you remember, it's like chlorine, fluorine, it's the ones we call the halogens, right? You remember that they need one more electron, and these guys like have one extra electron. So when you put them together, you get ding, perfect, right? It balances out. And so this is basically where your oxidation states are going to be. So if you're looking at a compound and you want to know what is the oxidation number for each of those particular atoms that make up that compound, you can just look at a chart like this and it'll show you. But if you have an understanding of what things combine with what and why, it makes perfect sense. So we have something called half equations or half reactions. And basically what this is it's either the oxidation or the reduction reaction component of a redox reaction. So remember, in a redox reaction, you have an oxidation reaction and a reduction reaction, and they're going on at the same time. So if you were to break them into parts, we call it a half reaction. And so here's an example. The reduction part shows what they're calling the oxidant plus its electron. It's reduced, it's gain. And then here, an oxidation reaction, you've got your reductant and then your product plus your electron. So in this case, your electrons in your reactants, and in this case, your electrons in your products.
The spaceship exploding, it was an oxidant.
Oh, it was an oxidant, that's for sure. It was it was an oxidant, all right. Yep. You know, another weird thing, anybody ever watch A Christmas Story? The one with the little boy who wants the rifle, the BB rifle? Yeah. Okay, that movie came out the same year. The Christmas before the Challenger event. So that little boy, Peter Billingsley, who played Ralphie, he was like real popular at the time, and he was at NASA watching it live. So when you look at like pictures of the crowd, he's in the crowd, which is really kind of weird. Like Ralphie's sitting in the crowd, like watching the Challenger explode. Yeah, it was weird stuff, man. It's real weird. So in this case, you notice reduction and oxidation. Oxidation is loss, reduction is gain, right? Okay, so here, let's watch this.
Maybe you'd rather exercise.
Maybe not.
Your mind. That's fine.
I'm so tired of commercials.
And I need to go.
Zenbeo? No.
Get rid of weight.
Oh, Zempic or Wegovy or those? Yeah.
My grandpa, the
Mhm.
other night, it played one of those ads,
Mhm.
and near the end, he said, "And there's still fat."
Yep. So here's how half reactions work, okay? Or half equations.
People learn how to write half equations for simple redox reactions. A half equation shows what happens at one of the electrodes during electrolysis. So we do need to be able to complete and balance half equations for these reactions.
So watch this closely because this is next
Remember
week's
that
lab.
oxidation occurs at the anode and reduction occurs at the cathode. Let's have a look at a simple redox reaction.
I know.
A strip of
Just too
copper
close.
wire is placed in silver nitrate solution. Over time, the solution changes color from colorless to bright blue. You will also
Do you remember
observe
when we did this
silver
reaction
metal
in class?
crystal deposits on what was once copper wire.
We did this reaction, do you
Why does
remember?
the solution turn blue? Pause and think.
I showed it to you.
This is a single distinct reaction. Copper metal, which is higher on the reactivity series, has displaced silver in silver nitrate. The solution has turned blue because of the copper-2 ions in the solution. This is also a redox reaction where a reduction and an oxidation are occurring simultaneously, hence the term redox. Remember that oxidation means the loss of electron and reduction means the gain of electrons. So for a redox reaction, electron transfer has to happen with one substance losing electron and another substance gaining electron. The silver nitrate is an ionic solution containing Ag positive and NO3 negative ions. So here is the equation again. All the ions shown separated. The copper
See how
metal
we've
has
broken
been
out into
oxidized
ions?
because it has lost 2 electrons to form Cu2 positive ions. If we take out this half reaction, we now have a half equation, whereas the silver ions have gained electrons to become reduced, represented by this half equation. Now are called half equations because each equation represents half a redox reaction, either the reduction reaction or the oxidation reaction. When the two equations are added together to form the final redox reaction, you can see that everything, including the number of electrons, are balanced. To reform the ionic equation, the electrons are equal on each side and can be removed. What about those nitron ions in the original equation? As the nitron ions appear on both sides of the equation, they are called spectator ions, as they have no effect on the overall reaction. Much like spectators in a football match have no effect on the final result of the game. Here is another redox reaction where the iron chloride oxidizes
Way too close to her mic.
ions
Yeah.
to iodine solid. See if you can write the 2-half equation. Pause the video and work out the answer. Did you get
So
it
watch
right?
how she does.
The iron is reduced and so gains an electron. The iodide ions are oxidized and so lose the electrons to form iodine. So in summary, half reactions represent either an oxidation reaction or a reduction reaction of a redox reaction.
All right, so next one, there we go. All right, so how do you identify your agents in your redox reaction? So your oxidizing agent is what adds oxygen to another substance or removes hydrogen from it. And your reducing agent is what removes oxygen from a substance or adds hydrogen to it. So what did the oxidizing agent say to the reducing agent? Anybody want to guess?
Oh, look at that old
What do you
meme.
think?
Why do you get redox?
When you get redox, what did the oxidizing agent? So the oxidizing agent removes oxygen or adds hydrogen. That's your reducing agent, and your oxidizing agent is going to be adding oxygen or removing hydrogen. So what did the oxidizing agent say to the reducing agent? Your loss. Oh, goodness. I mean, so your weekly homework question this week is going to be to research redox reaction in everyday life. Describe one example and list its chemical equation. And tell us what are the oxidizing and reducing agents. So some examples might be combustion. Yeah.
Oxidation.
There you go. Yeah, like rusting. So combustion is an oxidation reduction reaction that occurs so rapidly that noticeable heat and light are produced. What's corrosion? Anybody define it?
Rust.
Iron corrodes. Yeah, can be rust. Yeah.
I don't like rust.
So corrosion is an oxidation reduction reaction in which a metal is oxidized and oxygen is reduced, usually in the presence of moisture, right? Right. Anybody ever have anything out that you leave outside and it gets rusty?
My brother left a coin of pennies in vinegar and it got rusted.
Oh, pennies and vinegar. That's interesting. Wonder what caused that. Sometimes I have to be really careful with some of our lab stuff when I wash some of the metal items that aren't like stainless steel, for example. They will sometimes rust. Do you know what stainless steel means? It's an alloy
It's
that
not stained.
it doesn't rust,
It makes-
basically. That's what it's supposed to be. You know what that probably is? It's probably nickel. Most people that are allergic to jewelry are allergic to nickel. Ask me how I know. So
Because
I
you
am
are.
super allergic to nickel. I have to be careful with sunglasses that have metal arms if they touch me. The snap on the back of jeans, you know, your little button on your jeans, sometimes the back of that has nickel in it. And I'll break out here. It's why I don't wear a watch, because most watch clasps have nickel in them, nickels and everything, because it's inexpensive. And only his ears, well, my ears, my everything, my hands, all my rings. Like, I can't wear fun costume jewelry ever. All my jewelry has to be like gold, nickel-free silver. Like, this is almost nickel-free. This is 99.7% nickel-free. So I can get away with that. Same with the chain. But like, most of my silver jewelry is got to be like James Avery level silver. It's got to be like almost completely free of it, because I will break out every time. So yeah, usually if you have a problem with jewelry, it's almost always nickel that's the problem,
My
because
dad-
people can react to nickel. You don't react to gold. Nobody reacts to gold, which is why they use it for fillings and things.
My dad's 6'4". Also, I heard that taller, skinnier people are more likely to have their lungs suddenly collapse.
Oh, wow, that's an interesting one. I haven't heard that.
Oh, is it because of the slim body?
I don't know. I haven't
It
heard that one
tightens.
before. I mean, I know there's people with certain syndromes that have that issue that happen to be tall and thin, but that could be. I don't know. That's interesting.
Why do lactose intolerant people eat a bunch of milk and stuff?
And then pay for
Well,
it later.
But no. But then people with allergies, they don't touch it.
So it's different. So lactose intolerant means your body has trouble breaking down the lactose, and you can actually take an enzyme. Oh, there's that word again, to help break down that lactose so that your body doesn't react to it with GI upset. But allergies are different. So if you're allergic to milk, it's usually not the lactose, it's the casein, which is the protein in the milk that you're allergic to, whereas lactose is the sugar. So the casein in the milk that you're allergic to causes your body to react with an allergic reaction, and that's totally different than being lactose intolerant. Like, my best friend's lactose intolerant, but she's not allergic.
People, did you know you can die from being lactose intolerant?
If you get sick enough, you'll dehydrate yourself. You don't want to die that way, trust me. That's a miserable way to die. That's a liquid coming out of both ends. Yeah. Huh?
And now it's like pink and it's safe and pink.
Yeah. And you know what's weird with me? I haven't worn a watch in years, because in probably 20 years, actually, because of the 20 to 30 years, because of the nickel, but it's still in my tissues, because if I get really, really, really hot and really, really, really sweaty, the rash will come back. Because it's still in there. It's like in there, and it'll activate. Okay, let's go through these last couple, because finish up, because I want to go through these and I want to hear the fish incident. We got 3 minutes, quick.
You can die from drowning and because you clogged the toilet.
Oh, there's that.
And it fills the bathroom in your house.
Well, you can die from dehydration if you are sick enough. All right, so oxidation, we said before, is a process in which a chemical substance takes on oxygen or loses electrons. And,
The battery.
Yeah, batteries. An oxidizing agent is a chemical substance that gives up oxygen or takes on electrons from another substance. A reducing agent is a chemical substance that takes on oxygen or gives up electrons to another substance. And a reduction, again, is a process in which a chemical substance gives off oxygen or takes on electrons. Annabelle, tell me about the fish incident. You have 2 minutes.
One time, so we were in Alabama, and we were after the pontoon boat. We all had fried fish, and it all seemed pretty good until later that day. Mama started throwing up everywhere. It got everywhere, but on my side of the bed. It got in her eyes, in her face, on the floor, on the side of the bed, everywhere.
Yep.
It traumatized me, and she learned the hard way that she can't have fried stuff except French fries.
Oh, yeah. Sometimes fried stuff will get you.
My mom is insanely hates cockroaches.
Oh, well,
And
who can
one
blame
time
her?
she
They're
went
not
to
fun.
a taco place she loved that place, so they kept going back.
Yeah,
Until one
I was
day,
gonna say, it got ruined, didn't it? Yeah.
until one day, she was walking up to get a taco and saw a cockroach crawl out of her taco.
Not okay.
And she screamed, and that traumatized
We
her.
used to have a hibachi place that we really liked, and my sister-in-law and my brother-in-law were in town, and we all went there. And you know how they bring out the little salad with like the ginger peanut dressing before you eat the hibachi? They brought out the little salad, and this baby cockroach crawled off my brother-in-law's plate, and we were all like, "That's it, we're done, never again."
So Lucy, I got